Today, we are looking at a turning point of a function. When we talk about a turning point, we mean in different graphs. For example, when you have a quadratic function, for instance, fx is equal to x squared plus 2. This is a quadratic function. This function can give us a curve like this one. And when we have a function which is like minus x squared, let's say plus 2, this one will give us a curve which is facing downward. In such a curve, here is our turning point. And in such a curve, here is our turning point. Normally, this is known as a minimum turning point, and this one is known as a maximum turning point. For the minimum turning point, the curve is a U-shape. And for the maximum turning point, a curve is an N shape. To get a U curve, definitely the coefficient of x squared has to be positive. And to get this curve, the coefficient of x squared has to be minus. When we talk about this turning point, it is also known as a stationary point, a no movement point, stationary point. Now, our aim today is how do we find a turning point when given a function. But in another function, let's say cubic. In a cubic function, such as fx is equal to x cubed, maybe plus x squared minus 10x. This kind of graph has two turning points. It has got the maximum and it has got the minimum. And this one has two turning points. It has got the maximum and it has got the minimum. So once I have a function which is quadratic and I need to find turning point, I will end up with one answer. But when I am finding turning point and it's a cubic function, I will end up with two answers. That is 1 and that is 2. Why two turning points? Because for a cubic function, we always get two turning points, one being the maximum turning point and the other one being the minimum turning point, as we can see. Now let's see how we find the turning point when we are given a quadratic graph. So for a quadratic function, if I have a function such as fx is equal to x squared minus 2x minus 8. This function, I can change it to equation and it will become x squared minus 2x minus 8. Now I'm going to use two methods. First, I'm going to find the turning point using the completing square. So first, I'm going to use completing square. And we know when we are doing completing square and the coefficient of x squared, like if ax squared plus bx plus c, when a is 1, we can use the formula which is summarized as there. So if I get my value of b as -2, So I keep negative 2 here. Negative 2 divided by 2, I'll get x minus 1 square. Minus, I keep negative 2 there. Negative 2 divided by 2, I get negative 1. When I square negative 1, I get positive 1. I keep it here. And my c is directly negative 8. So I keep here minus 8. Hence, I complete my square and I get that. So from the completed square, the constant value which is outside the square represents the y value, and the x which will make this all statement 0 will be my x reading. So if I have minus 1, then my turning point will be positive 1. Because if I keep here positive 1, minus 1, I'll get 0. So as simple as I take the opposite sign of this number, and this is my turning point using completing the square. Now, I need to find again the same turning point, but I'm going to use the derivatives by derivatives. So I need to first find derivative of y in terms of x, and I'll get my dy dx as 2 times 1, that is 2x. 2 minus 1 is 1, so I don't write 1. Then here, power is 1. 1 times 2, I get negative 2. And then 1 minus 1 is 0, so the x is gone. And normally, for derivative, the constant value will always disappear. Now, the rule says for the stationary point, 2x minus 2 will always be equal to 0. So now I have 2x is equal to 2 by taking 2 this side, divide by 2, and hence I get my x as 1. So after getting my x as 1, I go back to the original function and I find y. So on the place of x, I keep 1. On the place of x, I keep 1. And finally, I will get my y value as negative 9. And my turning point will be the value of x and the value of y. So I end up with the same turning point. Here I used completing square. Here I use dy dx to get the turning point. Let's see second example on the same quadratic. Fx is equal to x squared minus 4x plus 1. Fx is equal to x squared, 4x minus plus 1. So first I will use a completing square. So I start by completing square. Okay. So when I'm completing the square, as we said at the beginning, x plus b over 2 square minus b over 2 square plus c is the formula when the coefficient of x squared is 1. And here the coefficient of x squared is 1, so we can easily find the turning point. So here I will substitute my b, that is negative 4. When I substitute here negative 4, I get 2. So that will be x minus 2 square. Then this will be minus 4, and this will be plus 1 because my c is plus 1. And finally, I'll get minus 3 because minus 4 plus 1 is minus 3. So again, my x will be positive 2 because if I keep positive 2 here, I get 0. So it's a matter of saying negative 2, change the sign, and the number which is outside, that is minus 3. That is my turning point using completing square. But how do we get the turning point using derivatives? By derivatives. That is dy dx. So dy dx of our function will be 2x, because that is 2 times 1, 2x, then 2 minus 1, it remains power 1. Then minus 4, because here there's 1. 1 times 4 is 4, and then 1 minus 1 will be 0. So when we want to find the turning point, always this has to be equal to 0. Hence, I have 2x is equal to 4, divide by 2, and my x is 2. So after getting x, you substitute the x in the function, of which is the original function, which is there, x squared minus 4x plus 1. So substitute 2 to find y. So y will be equal to 2 bracket square minus 4(2) plus 1. And finally, my y would be, so y will be minus 3. So if my y is minus 3, I can write my turning point now. X is 2 and y is minus 3. And finally, you will realize the turning point which I got using completing square is exactly the same as the turning point using derivatives. Now, the aim for me to show you that we can find the turning point using derivative for quadratics, it is because when we come to cubic, the most efficient method of finding turning point is derivative straight away. So let's see how we use the derivative method straight away to find the turning point of a cubic function. So now let's look at the turning point of a cubic function. But for cubic function, straight away, we are going to use our derivatives. So cubic function. So we are going to have example 1, and we have fx is equal to 4x power 3 minus 3x plus 3. So we find the derivative for this. So dy dx will be 3 times 4, that gives us 12. X, then 3 minus 1, it remains power 2. The next, here there is power 1 times 3, we get minus 3. Then x power 1 minus 1 is 0, it's gone. So our dy dx will be this function. But remember we said, for stationary points, 12x squared minus 3 is always equal to 0. So I'll get 12x squared is equal to 3. That is if I take 3 this side. Then I divide by 12, I will get x squared is equal to 1 over 4. Then when I square root both sides, I will get my x is equal to plus or minus a half. So this means my first x is a half, my second x is negative a half. So after getting those x readings, I go back to the original function, that is y is equal to 4x power 3 minus 3x plus 3, and I substitute these two values so that I can get the y reading. Therefore, for y1, I'll keep half. So I'll get 4 a half power 3 minus 3 a half, then plus 3. And my y1 will be a 2. In the same way, to get y2, I will substitute a half in my function, that is negative a half, because the first one I substituted positive a half. And remember my two x's, one is positive, one is negative. When I substitute this and I work it out, I get y2 as 4. Then finally, now I have my x and y, so I write my final answer. That is my turning points. The first turning point, x is half, and then the y is 2. The second turning point, x is minus half, and then y is 4. So this is how you find two turning points on a cubic function using derivative approach. Let's look at a second example of finding turning point of a cubic function, finding turning point of a cubic function, but using derivatives. So given our function as x power 3 minus 7x plus 6, so we find dy dx, the derivatives. So dy dx will be 3 times 1, 3x, 3 minus 1 becomes power 2, 1 times 7, 7, then 0. So my dy dx will be that one. But remember, for these derivatives to give us stationary points, they have to be equal to 0. So I will say this is equal to 0. Then I will work it out. 3x squared is equal to 7 because I have to bring 7 that side. Then divide by 3, divide by 3. So I get x power 3 is equal to 7 over 3. Sorry. Then I do square root. I get my x is equal to plus or minus 1, because this will give me decimal answer. 1.5275 etc. according to the calculator values. So this tells me I have got two values of x. I'll write them down. The first x reading will have a positive answer, and that positive answer will be 1.5275252232. Full answer from the calculator. And then the second one will have minus 1.5275252232. Then I must use the full calculator answer to find the readings for y. And remember, my function is x power 3 minus 7x plus 6. So I will substitute this reading here on the place of x. For example, y1 will be equal to, open bracket, keep 1.527 dash dash dash, meaning you have to keep all the calculator value. And then also here 27 dash dash dash, meaning the whole calculator value. Then you work it out, and I end up with negative 1.128451081. I do the same for y2. I will substitute the negative 1.5 value, power 3, in the original function. And then 7, 1.52, then plus 6. Then I keep my calculator and I get my my final value for negative, and it will be 13.1284510.8. Then finally, after getting both the values, when we're writing the final answer, then we can round off, but we cannot round off as we are doing. That's why I was keeping all the reading of the calculator. So I can say my x reading is 1.53 and my y reading is negative 1.13. That's my first turning point. And my second turning point would be negative 1.53, comma, and 13.1. That is how we find turning points using the y, the x, and that is using the derivatives. So we started with a quadratic function. We saw how we find the turning point using completing square, and we also used derivatives and we found the turning point, and we ended up with the same answer of turning point. After that, we looked at how do we find the turning point on a cubic function, and we saw we find dy dx equal to 0 for stationary points. We get two values of x, then we substitute on the original function to get the two answers. So this is how we find turning points using derivatives, dy dx. Thank you for watching. If you enjoyed my video, please subscribe to my channel. I will be posting more videos of mathematics. My name is Mr. Ishengoma.